Okay, and now we're on the letter E, and you're probably wondering, where on earth did D go? Well, now we know why there was 2 D's in the other lesson, because there's none in this one apparently. Don't worry about it. We are on problem E. We have 1/2 P plus 7 equals 3/4 P plus 9. Now let's not get too excited about the fact that there's fractions involved. You're perfectly capable of doing this. Notice we have 2 different denominators once again. So the first thing we're going to do is get a common denominator, so we have fourths in both cases. 1/2 we should all be able to easily see is 2/4 P. So we have 2/4 P plus 7 equals 3/4 P plus 9. So the first thing we're going to do is get rid of the lower of the 2, and 2/4 is obviously less than 3/4, so we subtract 2/4 from both sides, and we have, this cancels out, so we have nothing but 7 on this side of the equation equals 3/4 minus 2/4. We should recognize as 1/4 P plus 9. Now before we go on from this, I want to point out, if you can look at this and recognize that I'm going to subtract 1/2 from both sides, and if I subtract 1/2 P from 3/4 P, that will leave over 1/4 P. Then go right ahead and jump to that. We should start seeing that in the 8th grade, that we can recognize if I had 3/4 of a pi and I took half a pi away from that, there would be 1/4 left. So go right ahead and go to that if you can. The next step is to get rid of the constant, which means I have to subtract 9 from both sides. 7 minus 9 is -2, and that cancels this out, and we're left with 1/4 P on the other side of the equation. Obviously, we then need to multiply by 4 to get rid of that denominator. Multiplying both sides by 4, we get -8 equals P. And then we can put -8 into the solution here. And I want to point out to you that you can do, some of you can probably even check this in your head, but at the very least you should put this in your calculator and check. But let me show you how to do it in your head. What is 1/2 of -8? Well, that's -4, obviously. So -4 plus +7 is +3. What is 3/4 of -8? Well, if you just imagine, you separate -8 into 4 equal piles, what is 3/4 of that? That would be -6. -6 plus +9 is indeed +3. Done in the head. Some of you are very capable of doing that. Challenge yourself to do as much mental math as you can. It will make math fun. Letter F. -5/4 C minus 1/2 equals -3/4 plus 5/8 C. First step, we need a common denominator with our variable. Obviously it's 8, so we double both numbers here. We have -10 C. Taking a look at it, negative C is less than any amount of positive, so we're going to add that amount of C, which 10/8 C, to both sides of the equation. These cancel out, and we have nothing but -1/2 on this side. We then have 5/8 plus 10/8 would be 15/8 C. Don't be tempted to turn that into a mixed number. Just leave it improper like it is. This is always going to help you out in algebra. Just leave it like it is for now. So we have 15/8 C. Now we take a look at these. We've got fourths and halves. So again, if you could do that in your head without converting, go right ahead. But my guess is we probably want to turn this into -2/4. So we'll carry that up on the next board. So we have -2/4 equals -3/4 plus 15/8 C. The obvious step is to get rid of the constant. That's all that's left on this side with the variable, is to get rid of the constant. So we add +3/4 since it was negative. Adding +3/4 to -2/4 would give us +1/4. And the next thing we want to do is carry down, this is canceled, so carry down the 15/8 C. Now, the obvious next step is to multiply by the denominator. Multiply both sides by 8, and I get over here, the 8 over the 8 cancels out, and I get 15C. Over here, it would be 8 times 1 over 4, or 8/4, and we can do that in our head. 8 divided by 4 is 2. So we have 15C equals 2. Next step, obvious, divide by 15. And once again, in algebra, don't put this in a calculator and give me a decimal answer to this. Leave it as 2 over 15. 2 over 15. 2/15 is your answer. Now this would be a difficult one to plug into the original equation. You could change them to decimals. That probably would be the best. If you got this answer, congratulations to you. You did a very nice job. please press pause and do the guided practice. Here are the solutions to Lesson 4 guided practice. Our first problem is 5n plus 9 equals 2n. Lower variable value is 2n, so we're going to subtract that from both sides. And this is a special type of problem that causes problems for many students, so we'll talk about that in a second. 5n minus 2n is, of course, 3n plus the 9. The key thing here is many students will just look at that and see there's nothing here, and they will write the equation, they will move the equal sign in effect, and they will write 3n equals 9. That is not acceptable. We have something on this side of the equation that we can use to keep this place, and that is the number 0. 2n minus 2n is obviously 0, just like 5 minus 5 is 0. So you have to write the number 0 there, and of course your equal sign is here, not over here. So now we have 3n plus 9 equals 0. What do we need to do? We need to get rid of that constant on that side, on the variable side of the equation. So we do that by undoing, by subtracting. Subtract 9, and we have 3n equals negative 9, 0 minus 9. And now we can divide both sides by 3 and get n equals negative 3. Really take a good look at this. This is a very problematic problem for many students. And then, of course, I'm going to just ask you if you checked from now on, because you would have caught this mistake if you put your answer in, and you would know that you did something wrong, and it would alert you to try and figure out what you did wrong. Always learn to check your answers. It's pretty easy to do, especially in this case. There are only 2 calculations here, really. Problem number 2. 7y minus 8 equals 6y plus 1. Lower variable is 6y, so subtract 6y from both sides. Some of you will like to put the 1y there. That is perfectly acceptable. Go right ahead and do it, but you're not going to see it that way in books, so it probably isn't a bad idea to get used to looking at y and thinking 1y. So we have y minus 8 equals positive 1. Obvious step is to add 8 to undo the subtraction of 8, and we get y, or 1y, equals 1 plus 8, which of course is 9. Plug it into your equation, check. Problem number 3. 3/5 x minus 15 equals 6/5 x plus 12. We're going to get rid of the lower portion of the variable, which is 3/5, and to do that we're going to subtract 3/5 from both sides. This cancels out. We have negative 15 equals 6/5 minus 3/5. Should be easy to do in the head. 3/5 x, and carry down the plus 12. Obvious next step is to get rid of that positive 12 by subtracting it. Subtract 12 from both sides of the equation. We get 3/5 x equals negative 27. Because it's all negative, we can add it up and apply the negative sign. We need to multiply by 5, but there is an easier way to do this that I will get to in a minute, and I want you to learn to see these types of things. But the method we've been taught is multiply by the denominator on both sides. 27 times 5 is 135, and it's negative. 5 times 5 cancels out, and we have 3x. Our next step then, of course, is divide by 3. Negative 135 divided by 3. Some of you probably had to reach for the calculator there. We have x equals negative 45. The reason I say there's an easier way to do this is you should look at this and remember that in PEMDAS, multiplication and division are considered together. So if I'm going to do 2 things, you should know right here that I'm going to multiply by 5 and I'm going to divide by 3. Immediately when you look at that, that's what you've been doing for several lessons now. Well, since you're going to do that, you can look at 27 and say, wait a minute, that's easily divisible by 3. So take the negative 27 and divide by 3 first, because order of operations allows us to do that. Negative 27 divided by 3 is easy in the head. That's negative 9. Now all I have to do is multiply by 5. Also easy in the head, negative 45. Much easier route to do it this way, all done in the head. Remember your order of operations and the power that math gives you if you understand the process and what you're doing. Number 4, they ask you, at what point is the mileage the same? Okay, so in other words, they're trying to get you to set up an equation where you have this amount equals this amount, okay, which is exactly what we've been working on. So in other words, another way to put this is that when will plan 1 equal plan 2? And we're going to define a variable. M is going to stand for mileage. So Plan 1. Well, Plan 1 is easy. And they say that it's $40 plus 25 cents per mile. Well, in math terminology, that is 0.025, 25 cents, times the mile per mile, plus the original charge of 40, or the set charge of 40. Okay? The ACE plan, or plan number 2, is $25 plus 45 cents a mile. So that comes out as 0.45 M plus 25. And now we've said right in the beginning, these two plans are equal. That's the point we're looking for. So set this equal to this. So we have 0.25 M plus 40 equals 0.45 M plus 25. One plan equal to the other plan. Okay? So now here's our equation again. 25 100ths M plus 40 equals 45 100ths M plus 25. Obvious first step is to get rid of the lower variable, so we subtract 25 hundredths M from both sides. We've got 40 left on this side. 45 hundredths minus 25 hundredths is 20 hundredths, so we can put 0.20, or we can change it to 0.2 if we want, doesn't matter. And then plus 25, so we need to undo that by subtracting 25 from both sides. 40 minus 25 is 15, and we have 2/10 M. So the next thing to do, since we're multiplying by 2/10, is to divide by 2/10. And some kids will get confused about the fact that we divided and yet our number is smaller. Whenever you divide by a number less than 1, you will have an answer greater than you started with, because you're dividing by less than 1, 2/10. So another way to look at this is it's really like multiplying by 5, okay, because that's 1/5. And we have M equals 75, and of course our answer is 75 miles. And lastly, problem number 5, essential question. The key thing to remember is that when you have variables on both sides, it's all about you add one more step. Add the additional step of getting the variable on one side and then proceed as before. Once you get it to the point where there's only one variable on one side of the equation, you have the same type of thing you've been doing for quite some time now. However, I want to put in this point where it may include combining like terms. For example, in that problem, I believe we had 4W plus 2W minus 0.3, I think it was, on one side of the equation, and I think it was 14.4 plus W on the other side. The first thing you need to do is combine like terms and then go from there. But it's still a matter of getting a variable on one side and the constant on the other. Thank you.